Hey guys, so today we will do this question, which is to find um an element in the rotated array. So if you see, we have something which is a rotated array 4 5 6 7 0 1 2, and we have to find the target element, and it gives you an index because 0 1 2 3 4, right? So it is giving you the index. So that's the question, and the main thing is we have to do it in the log n complexity. And if it doesn't, if we don't find the element, then we have to do in return -1 to it. Okay, so let's get into our whiteboard, and let's copy this 4 5 6 7 0 1 2. So it's 4 5 6 7 0 1 2. So we have already done this, but in to find the minimum in the rotate search array, and this question is very similar to what we have done in the past with the rotated array. So there are two versions to this. As you can see, we start with the start index and the end, and somehow we find the middle, right? So when we find the middle, this is one version of the array, okay? And in this version, as we can see, we have target element which is 0, okay? So in this, we can see the target element is on the right? So the main point is to consider this version and come up with an algorithm. So as we can see visually, what's happening here is, how do we see that this version of array currently exists, this version of rotated array exists, right? So one condition that we have is the mid, ARR of mid is basically greater than ARR of end, right? So then we can say this version of array is existing, right? So if this version of array is existing, then it makes it easy to understand that we have to actually find the target element, right? And in this, basically a target element can be 0 or target element can be 6 or 5, right? Consider 5. So we can have two versions of target. Target can be either on the left or either on the side. How do we know the target element is on the left of the middle or in the right of the middle? That is the main thing. So once we identify that this version of array exists, right, then we have to actually see if the target element, which is ARR of target, okay, or maybe say just say target. So we can say if the target element, right, is let's say 0. So we need to say if ARR of mid is greater than target and target is less than ARR of end, right? So if ARR of mid is greater than the target, right, this will be applicable for all these and even for this, right? And target is less than ARR of end, or maybe less than equal to ARR of end, right? Then in this case, what we have to do, we have to shift our start pointer to here, right? So the start would be mid plus 1, right? Else, the else condition of this, if that's not the case, then it exists here, right? So in this case, end would be mid minus 1, correct? So the end would actually shift from here to here, because then if it doesn't exist here, it has to exist here. That is, this is one case, okay? The second part of this is, this version of array does not exist. So the another version of array is the other version, right? where the minimum is on this side. So let's say this 7 0 1 2 4 5 6. Okay, this is another version of array. So in this case we have middle, start and end. Okay, so in this is an else condition of this. So here we said mid is greater than the end, and here the else is mid is less than the end. Okay, so in this case we can have target, either we can have target this or we can have target this, right? So suppose target is 5 in this case. So in this else condition we'll say that if the target, say it's 5, okay, so if we say if target is greater than mid, right, and target is less than ARR of end or less than equal to, because it can be 6 also, right? So if target is greater than mid and it is less than, then we have to do start equals to mid plus 1, right, because the start will come here, else it will be here, right? So in this case end would be mid minus 1, right? So this is how it will go, and the breaking condition of this would be if mid is equals to target. Then this is the basic binary search, right? So if middle equals to target, then we will return the ARR of mid, or we'll just return mid because we need to find the index, right? So let's do this. Let's program this. So we'll say public static void search rotated element int ARR int target, and in this case what we'll do, we'll start with basic binary search elements. So we have start, we have end, and we have middle. Okay, and then we have while loop, while start is less than equals to end, right? We have to calculate middle, which is start plus end minus start by 2, right? So now the first condition that we have to see is if ARR mid, the first one, if ARR mid is greater than ARR of end. So we say if the first condition is if ARR of mid is equals to target, then in this case we return mid. Okay, this is the basic condition of binary search. So before that we have, okay, yeah, we did calculate mid, right? Okay, I think it's because of this. Okay, now we do else if. Okay, the else if says if this ARR of mid is greater than ARR of end, right? So if middle is greater than end, then we say if. Okay, now we need to check the target, right? So this condition. So if ARR of mid, if the target for example is 0, okay, so in this case if ARR of mid is greater than the target, so ARR of mid is greater than the target, and target is less than equal to ARR of end, because target can be 2 also, right? If it's mid, then we already catch it here. Okay, but if it's end, we have to make it equal to, right? Then in this case we have to say, if it's here, then we have to say the start has to be mid plus 1. Start has to be mid plus 1, else it will lie here, so it will be, maybe it's 5, right? So in this case the end has to be mid minus 1. So this is one condition which covers this version of array. Now the second version of array will come inside this if. Where is the if, else if? Okay, yeah, else inside it we have, so if ARR of mid is greater than ARR of end, mid is greater than end, so here the next version is where mid is smaller than end, right? So if mid is smaller than end, 2 is smaller than 6, so this is second version of array. In this case we have to see target element, so target element for example is 5, right? So we say if target 5 is greater than ARR of mid and target is less than equal to ARR of end, again the same thing because target can be 6 also, so we do start has to be mid plus 1, okay, else meaning this is not the case, then it has to be here, so end has to be mid minus 1, the end has to be here, so because if this is not true then the target would be maybe 0, right? So end will be mid minus 1, so end would be mid minus 1. Finally, if nothing is there, then we have to return okay, then we have to return minus 1, right? So we'll say return minus 1, okay, because it says return minus 1. Okay, now let's try to run this program. So we'll make a public static void main and we'll say int ARR is 4567012, okay, and system dot out dot println, and we'll just pass this search rotated element, and then we'll say ARR and we say 0, okay, so the answer has to be 4. Okay, I am getting answer as minus 1. Why is that? So if ARR mid equals to this, return this, which is correct. Mid equals to this, which is correct, and then we go else if. Oh, this is what it was missing. This equal to is the one that creates problem. So the point is ARR of mid is greater than equal to ARR of end. That is correct, because if there is a single array, if there is a single element, then the start, mid and end would be the same element, right? And that is why we have to check if ARR of mid is greater than equal to ARR of end, right? And similarly we have to put the same thing with this. ARR of mid is greater than equal to target. It has to be inclusive. Let's try and see if it works fine. No, it's still not working. Why is this not working? So I think, did I do something wrong? If target is greater than mid and target is less than equal to end, then start equals to mid plus 1, else end equals to mid minus 1, and then you have this, and then inside it you say if target is greater than mid and less than end, greater than mid and less than end, it has to be mid minus 1. No, something is wrong. Why is 0? Does it work for 4? Okay, it's working for 4. It's working for, oh, okay, I need to check why this thing is not working. So let's see, 4 5 6, let's clear this. 4 5 6 7 0 1 2, and we have while start is less than equals to end, so start is there, end is there, end equals, oh, okay, I got it. That is the problem. Okay, silly mistake, but now it will work. Yes, it's working fine. Yes, that was the problem. I didn't see that I'm not putting end as array.length minus 1. Yep, this is the problem, and time complexity is logarithmic. I hope you guys are able to understand, although some confusion, but I guess you guys would have figured it out more early than I, that end is 0 somehow by mistake. Thank you guys.